Hi everyone. This is another question for shaft. I can read the question. A shaft is supported on bearings A and B, 800 mm between centers. A 20-degree straight tooth spur gear having 600 mm pitch dia is located 200 mm to the right of the left-hand bearing A, and a 700 mm diameter pulley is mounted 250 mm towards the left of the bearing B. The gear is driven by a pinion with a downward tangential force, while the pulley drives a horizontal belt having 180-degree angle of wrap. The pulley is also serves as a flywheel and weighs 2000 Newton. The maximum belt tension is 3000 Newton and the tension ratio is 3:1. Determine the maximum bending moment and the necessary shaft diameter if the allowable shear stress of the material is 40 megapascal. So this is the question. In this question they are giving two bearings. In between two bearings there we have one pulley and one gear. So we can write the given data first. Given that the bearing distance, that is A and B, is equal to 800 mm, the alpha is given, it is for the gear, that is 20 degree. Then D diameter of the gear is also given, pitch diameter, it is 600 mm. We can write it into radius also, that is 300 mm. Then AC, the distance between one bearing, that is left hand bearing, and the gear is 200 mm. Then next one, the diameter of the pulley is given, that is equal to 700 mm. Then next one, the distance between the pulley and the right side bearing, that is equal to 250 mm. Then the angle of wrap on pulley is given, that is 180 degree. The weight of the pulley is given, that is equal to 2000 Newton. Then the tension at the tight side, it is also given on the pulley, that is equal to 3000 Newton. Then the ratio is given, T1 by T2 is equal to 3. Shear stress is given 400 Newton millimeter square. So these are the given data. Now we can draw the space diagram. This is the space diagram. The distance between A and B, that is equal to 800 mm. Then we have one gear and another pulley is also on this shaft. The distance between the gear and the left hand bearing is 200 mm. It is already given in the question also. The distance between pulley and right hand bearing is 250 mm. Then they are given that we have horizontal direction on the pulley because the belt tight side is marked as T1 and the slack side is marked as T2. Then next we have the gear have an angle of 20 degree involute, so it have horizontal and vertical directions that I can explain later. Now we can start the conditions. First of all, we can find the torque. T is equal to T1 minus T2 into RT, but here T2 is not given, only T1 is given. So but we can convert the value T1 by T2 is equal to 3T in this form. So take T1 outside, then we can convert that equation into T1 into 1 minus T2 divided by T1 into RT, or T2 by T1 is the inverse of T1 by T2, that is equal to 1 by 3. And in this equation all parameters are given. What is that? T1 is equal to 3000 and T2 by T1 is equal to 1 by 3 and RD is also calculated, that is equal to 350. So that value is equal to 700 into 10 raised to 3 Newton millimeter. So first we find the value of torque. Now we can draw the torque diagram. We can assume that the torque in between the pulley and gear are same. So this is the torque diagram. So we can draw the corresponding points A, B, C, D just below of that space diagram and mark the torque value 700 into 10 raised to 3 Newton meter. It is drawn like this, a rectangular box. Now we can find the value of the values on the load values on the gear. How we can find the values? First of all, we can take the tangential force FTC. For a gear, FTC is equal to T divided by RC. T we calculated and RC is given value. So the tangential value we can calculate it as 2333. Now the normal force acting on the gear. The normal force we can calculate using this equation. WC is equal to FTC divided by cos alpha C. Alpha is given 20 degree. So if we substitute this value, we will get that is equal to 2483 Newton. Now we can draw this figure, that is for a gear we can draw horizontal and vertical component like this, because it is 20 degree involute system. So we have WC cos 20 on the vertical direction and WC sin 20 on the horizontal direction. So we have two load, that is the horizontal load and vertical load. So we can calculate this load using this equation. That is the vertical load we can find using WCV is equal to WC into cos 20. What is that value? That is equal to 2483 into 0.9397. That value is equal to 2333 Newton. And next one, WCH horizontal component, that is equal to 2483 into 0.342. That is equal to 849 Newton. So we can draw the horizontal component and vertical component on the gear. This is the vertical component 2333 and this is the horizontal component 849 Newton. So on the next we can draw this vertical load diagram and horizontal load diagrams at point C, that is on the gear. Now we can calculate the tension side. What is that? T1 by T2 we already know that it is 3 and T1 is equal to 3000 Newton. So using this equation we can find the value of T2. What is that value? T2 is equal to 1000 Newton. So we have the horizontal component acting on the shaft D is equal to we can denote it as WDS, that is equal to T1 plus T2, or that is equal to 3000 plus 1000. What is that value? 4000 Newton. And in our question the weight is given, that is equal to 2000 Newton. So we can write the weight is on the vertical direction. So the weight we can show here at point D, that is equal to 2000, and the tight side and slack side load have 4000 Newton. That value we can mark it on the horizontal load diagram. So our vertical and horizontal load diagrams are completed. Now we can find the value for bending moment. How we can find the bending moment? For that we have to calculate the reaction load at A and B of each horizontal and vertical load diagram. The RAV stands for the reaction load at point A for the vertical direction and RBV is for the vertical load at point B. So in this diagram we can see that, from this diagram we can see that what is that value of RAV plus RBV. RAV and RBV towards the upward direction and point C and D are towards the downward direction. So we can write that RAV plus RBV is equal to 2333 plus 2000, that is equal to 4333. Similarly, next we can write that RAH and RBH. What is that? RAH is the reaction load for the horizontal direction at point A, and RBH is the reaction load at point B in the horizontal direction. So RAH plus RBH is equal to 849 plus 4000 Newton. This equations is written in this format. So this is the equation. RAV plus RBV is equal to 2333 plus 2000, that is equal to 4333. From this equation we can take take moment about A from the vertical load diagram. If we consider the moment about A, RBV into 800 is equal to this value. If we substitute, if we using this equation, if we substitute these values in calculator, we will get RBV is equal to 1958 Newton. Or if we using this value RBV, we can find that RAV. What is that? RAV is equal to 2375 Newton. And now we can take the bending moment. Bending moment at point A and B are 0. Okay. So we can, because there is a bearing, a bending moment at A and B are 0. Then next, what is the value of bending moment at point C? That is equal to RAV into that perpendicular distance, 200. RAV we already calculated, that is equal to 2375. If we substitute this value, we will get MCV, that is the bending moment at point C, is equal to 475 into 10 raised to 3 Newton millimeter. Similarly, MDV is equal to RBV into the perpendicular distance. RBV, we already calculated the value of RBV as 1958. If we substitute this value, we will get that the bending moment at point D. What is that value? 489.5 into 10 raised to 3 Newton millimeter. Similarly, on the same manner, we can find the value of MAH and MBH. How we can find? Before that, we have to find the value of RAH and RBH. How we will find RAH plus RAH and RBH? RAH plus RBH is equal to 4849. Using this equation, we can find RAH and RBH. Now we can take the moment about A, then we can write it as RBH is equal to 2963. If we find the value of RBH, then what is the value of RAH? That is equal to 1886. Then again consider the bending moment at A for the horizontal direction. Again at A and B, bending moments are 0. But we have the bending moment at C and D. How we can find? RAH into perpendicular distance. We will get it is this much of Newton millimeter. That is 377.2 into 10 raised to 3 Newton millimeter. Similarly, bending moment at D, 740.75 into 10 raised to 3 Newton millimeter. Now we get the two values for the horizontal and vertical bending moment at point C and D. These are the two values at the vertical direction, at the horizontal direction. Now we can find the resultant bending moment. How we can find the resultant bending moment? Using this equation, that is using this bending moment equation, that is MC is equal to root of MC square plus MCH square. That is the corresponding vertical and horizontal direction. We can get the value, we will get the value of MC. Okay. Similarly, we can find the value of MD also. MD is the resultant bending moment at point D. Take the bending moment at the horizontal and vertical directions. Take its square values, then add it. After that, square root this value. Then we will get the bending moment at D also. And which one is greater? At point C or D? We can see that at point D is bending moment is greater. So we have to take the value of maximum bending moment for our calculation. Now we can find the diameter for the shaft using the twisting moment equation. What is the twisting moment equation? That is equal to root of M square plus T square. The M value we calculated, it is the maximum of bending moment, that is 887.874 into 10 raised to 3 all to the power of square plus the torque. What is the value of torque? Torque is equal to 700 into 10 raised to 3 all to the power of square. If we substitute this value, we will get it is 1131 into 10 raised to 3 Newton millimeter. Then if we use the equivalent twisting moment, what is that value? T is equal to pi by 16 tau d cube. And the value of tau is given in our question. If we substitute this value in this question, in this equation, we will get the diameter of D, that is equal to 52.4. So we can convert it into standardized value, that is equal to 55 mm. Okay, thank you.